Hi, this is Coach Dorf. We're looking at problems that are similar to the homework problems, but not a homework problem. This is from section 4.4, problem number 43, and we're trying to find this limit here. So the first thing I would do when I have a limit problem is I would do direct substitution. So this has two terms multiplied together. So the first one is x. So what's the limit as x goes to infinity of x? Well, that's just infinity. We also have the limit as x goes to infinity of sine of pi over x. So let's look at that one a little bit more carefully. Let's first look what happens to the inside part. So what is the limit of pi over x as x goes to infinity? Well, in that case, pi is a finite non-zero number. So I have a finite non-zero number over something that's really, really large. In that case, it's going to go to zero. So pi over something that's really, really large, it's going to make the whole thing go to zero. So that means then that the limit as x goes to infinity of sine of pi over x is going to be, I'm going to have the sine of something that's going to zero. So that's going to equal the sine of zero, which is zero. So in this case, here we have the limit as x goes to infinity of x sine of pi over x, and that's going to have indeterminate form of infinity times zero, all right? And so that means that I should rewrite this in a form that I can get a rational expression that has 0 over 0 or infinity over infinity, and then I can use L'Hopital's rule. So how can I rewrite? So you need to rewrite x sine of pi over x. Well, I can do that one of two ways. So I can note that x is the same thing as 1 over x, or sine of pi over x is 1 over 1 over sine pi of x, which would be the same thing as 1 over cosecant pi x. So I could use either one of these. It's just my choice which one I would like to do. I'm going to choose to do the first one. So I'm going to rewrite x sine of pi over x to be equal to sine of pi over x all over 1 over x. All right, that's my new way to write that. And what's nice about that is now I have a rational, something like a fraction here, something over something. And then I can use L'Hopital's rule. I'll have to check it, but I should get 0 over 0 or infinity over infinity. So remember in the original problem here, we had something times something, and we got a 0 times infinity. That's an indeterminate form. To rewrite that so I can use L'Hopital's rule, I'm going to change it by putting one of those terms, either the one that goes to 0 or the one that goes to infinity. I'm going to put 1 over that in the denominator. So now my original problem was the limit as x goes to infinity of x sine pi over x. And now I've rewritten that as the sine pi over x in the numerator and in the denominator 1 over x. They're equivalent to each other. And I notice, what do I have here? Well, we remember from the beginning that the limit of sine of pi over x equals 0. So this one's going to 0 on the top. And on the bottom, as x goes to infinity, we have a 1 over x. And the limit of 1 over x as x goes to infinity is 0. Because I have a non-zero number over something that's really large, that's going to 0. So this has the indeterminate form of 0 over 0, which is great, because now I can use L'Hopital's rule. So we use L'Hopital's rule. And so I'm going to get this is equal to the limit as x goes to infinity of the derivative of the top, sine of pi over x, over the derivative of the bottom. So again, I'm going to make a little note here. What are these derivatives? Well, let's see, derivative of sine of pi over x. I'm going to use the chain rule. So I have the derivative of sine of something. Derivative of sine is cosine of that something times the derivative of what is in that parentheses. And in this case, what's inside the parentheses is pi over x. So here, I'm not going to have cosine of pi over x. And now I need to take the derivative of pi over x by the chain rule. Well, this is the same thing as the derivative of pi x to the negative 1 And now I can use the power rule. And that says if I have x to some power, I bring the exponent out front. So I'm going to have a negative pi x, and then I reduce the exponent by 1. So 1 minus 1 is negative 2. And so that's the same thing as the cosine of pi over x times negative pi 1 over x squared. And I'm just going to rewrite that. I'm going to bring the negative pi out front. So I have negative pi cosine pi x over x times 1 over x squared. Actually, I'm going to leave the negative there. Also, we have in the denominator derivative 1 over x, which is, you can rewrite that as the derivative of x to the negative 1. And it's very similar to what we did up above. By the power rule, that's going to be bring the exponent out front, so it's going to be negative x. Use the exponent by 1, so that's 1 minus 1. That's negative 1 minus 1, which is negative 2. And I get negative 1 over x squared. So I have my limit, x goes to infinity, of the derivative of sine pi over x over the derivative 1 over x. And that's going to equal, just computed the derivative, so we're going to substitute those in. So we're going to put this in here for the top. So we're going to get pi cosine pi over x times negative 1 over x squared. And in the denominator, we've got this, negative 1 over x squared. Now notice that both the top and the bottom have a negative 1 over x squared. So I can reduce those out. And then that gives me the limit as x goes to infinity of just pi times cosine pi over x. And that's going to equal pi because pi doesn't change. Right now I have the cosine of pi over x. We talked earlier that the pi over x, since pi is non-zero and x is going to infinity, that's all going to go to 0. So we're going to get the cosine of 0, which is 1. And so pi times 1 is pi. And that's the answer. Now you may ask yourself, way back at the beginning, we had the option of doing, I'll put in blue here, we had the option of doing either this or this to change my original function to make it go from the indeterminate form infinity over infinity into something that was a rational expression, something over something. And so I could then use L'Hopital's rule. We chose the first one. If you chose the second one, it would still work. When you did the indeterminate form, you would have gotten infinity over infinity, but you would have just done exactly the same method here. We had different derivatives, but the final answer would be exactly the same. In both cases, the answer was pi. All right, thank you.